Happy morning everyone. Level 1, level 2 questions in alkali metals. So come to the level 1 topic wise questions. First, general properties, physical properties, chemical properties, uses. Likewise, topic wise we are going to discuss the questions. Question number 1. Which of the following property is not true for an alkali metal? Here the 4 properties given: low atomic volume, low ionization enthalpy, low density, low electronegativity. When you observe in the periodic table, all the alkali metals are having higher atomic sizes comparing with other metals. When you see the periodic table, each and every period start with alkali metal: lithium, sodium, potassium, rubidium, cesium, francium. Coming to the last elements: helium, neon, argon, krypton, xenon and radon. Each and every period start with alkali metal and ends with noble gas. So while moving from the left to right, atomic sizes decreases. Atomic sizes decreases. In each and every period, alkali metal only the bigger atom. So that is the reason when atomic size decreases means obviously the volume also decreases. Hence, the correct option is low atomic volume. Low atomic volume. They are asking not true. Actually, the alkali metals are having higher atomic volume. So here they are given low atomic volume. This is a not a true option. In any period, alkali metal except noble gas has the low density. Therefore, alkali metals having large atomic volume. Question number 2. The reducing power of metal depends upon various factors. Suggest that factor which makes lithium the strongest reducing agent in the aqueous solution. Which factor influence when here the lithium smaller ion is acting as a highest reducing agent? What is the reason? What is the reason? Yes, hydration enthalpy. Because of hydration enthalpy, the lithium is having higher hydration enthalpy. Which sodium? When sodium is dissolved in liquid ammonia, a solution of deep blue color is obtained. The color of the solution is due to when alkali metal placed in a liquid ammonia. What color we are going to get it, ma? Here a blue color, deep blue color is getting because of ammoniated electron. Option 1. Ammoniated electron. Solubility of alkali earth metal hydroxides in water increases down the group because. So either alkali metals or alkaline earth metals, the solubility is in water increases down the group. Solubility is increasing. So because of which factor? The comparison is given in this case. Either lithium lattice energy is greater than hydration energy, or when lattice energy is less than hydration energy, lattice energy is equal to hydration energy, or insufficient data. The solubility is absolutely depends upon lattice energy and hydration energy. In any group from top to bottom, atomic sizes increases. Lithium ion is a smaller atom, will go to the last one, cesium ion is the bigger atom. When you go for alkali earth metals also, beryllium is the smaller atom. When you come from barium and radium is having a very big sized atom. Atomic sizes increases means what will be decreased? Hydration energy decreases. Hydration energy decreases. At the same time, lattice energy also decreases. Remember students, lattice energy also decreases. comparison, lattice energy and hydration energy, which will more decreases? That is a question here. So, lattice energy is slightly decreases comparing with the hydration energy. So, that the right option is second one. Among alkali earth metals, hydroxides, the anion being common, the cationic radius will be influence the lattice energy. Since lattice enthalpy decreases much more than the hydration enthalpy, which increasing ionic size, the solubility increases as we go down the group. So, this here given lattice energy, lattice enthalpy decreases much more the hydration energy with increasing in atomic size. The solubility increases, lattice energy much more increasing from top to bottom. Which of the following has lowest thermal stability? Which of the following has lowest thermal stability? Here thermal stability you have to explain with respect of forming of bases. Lithium forms base, sodium also forms base. What is the base of lithium? Lithium hydroxide, sodium hydroxide and potassium hydroxide, KOH, and rubidium hydroxide. In this case, which hydroxide is a weak and which hydroxide is strong? When you place it in water, the base which will release more number of OH ions, more number of OH minus ions, such kind of base is strong base. Remember students, the cation size is high, the attraction between RB and OH is very less. Because of this reason, the OH minus ions easily formed in the water. So, here this base is strong, this base is weak. If base is weak, thermal stability of their salts also weak. Hence, the right answer is this. See here, the weaker the base, the less stable is its carbonate. Since LiOH is the weakest base, hence Li2CO3 has the lowest thermal stability. Which of the following does not form an oxide on heating? On heating, only one cannot form oxide, that is sodium carbonate. Which of the following bicarbonate does not exist as a solid? Now only we have learnt about less stable will having does not form. So that the seventh one we are going to get the right option is fourth option. Which of the following is most stable? Sodium nitride, lithium nitride, potassium nitride and rubidium nitride. So these are all alkali metals, nitrides. So potassium nitride is not possible to form, rubidium nitride not form and sodium nitride not form. Only the possibility is there, lithium only because of smaller size it forms nitride. So this is a stable nitride. The right option is second one. Only lithium nitride is stable, other are not formed at all. Which of the following halides crystallizes from its aqueous solution as a hydrate? So, which of the following salts available in the form of hydrated? Yes, already you got the answer. Yes, that is the first option is available in the hydrated form. Remaining salts not available in the hydrated form like LiCl, H2O. Lithium salts become, because of their smaller size, usually crystallizes from their aqueous solution in the form of hydrates. Li2O2 is formed when? When the Li2O2 will be formed. What is the name of Li2O2? Lithium peroxide. In which conditions it will be formed? When lithium hydroxide is treated with hydrogen peroxide in presence of water, you will get the lithium peroxide. So this is about the chemical reaction. So that which is the right option for this 10th question is the fourth one is the right option. The order of solubility of lithium halides in non-polar solvents follows the order. Solubility which will soluble. All lithium compounds are dissolved in the non-polar solvents because of their covalent character. So, which will soluble more, which will soluble less? What is the correct order? Absolutely, the first one only the right option. No need to go for any other. So, lithium fluoride, this lithium fluoride, fluorine, smaller atomic size. So, polarity, electronegativity is high, definitely it is having the polarity. In the same way here lithium iodide, it is having higher atomic size than lower atomic size, lower atomic size and lower atomic size. See the answer? As the size of the anion increases from fluoride to iodide, the covalent character increases and hence the solubility in non-polar solvents increases. This is more covalent. So, covalent character is having increases and hence the solubility in non-polar solvent increases. So, more soluble compound, non-polar compounds are soluble in non-polar liquids. Casticization process used for the preparation of. In which process this we can prepare? Yes, the right option is the first one, caustic soda. Caustic soda means what, ma? NaOH. NaOH we can prepare in this method. See here NaOH, Na2CO3 plus calcium hydroxide, you are getting calcium carbonate plus NaOH. Sodium carbonate is manufactured by the Solvay process. The product those are recycled are. It is the preparation method. The right option for the 13th question is first option. The addition of sodium carbonate to the aqueous solution of an oxide produces CO2. This reaction indicates that oxide is basic, oxide is amphoteric, oxide is that of metal, oxide is that of non-metal. Yes, oxide is basic. All non-metallic oxides are basic in nature. Basic rule. Non-metal oxides being acidic decomposes on carbonate to evolve carbon dioxide. Common table salt means sodium chloride becomes a moist and does not pour easily in rainy season because the table salt contains the impurity of magnesium chloride, which is hygroscopic in nature. Pure NaCl never becomes moist. In Solvay process, ammonia sodium bicarbonate is precipitated due to what? Ammonium carbonate, when it reacts with sodium chloride, you are getting ammonium bicarbonate and ammonium chloride. So, ammonium bicarbonate, formation of ammonium carbonate, this is called as precipitation. So, precipitation, this is the precipitate, sodium bicarbonate is formed because of this reason. So, the right answer for the 16th question is first option. Gunpowder is, so gunpowder, absolutely the potassium metal can utilize. In this way, either first option or second option will be right. Yeah, the correct option for this is the first option. Gunpowder contains the mixture. Molecular formula of Glaber salt is, what is considered as a Glaber salt? The Glaber salt means sodium sulfate 10H2O is known as Glaber salt, not glamour, Glaber salt. The salt added to the table salt to make it flow freely in rainy season is. Which is the right answer? Third option is the right option. That is calcium phosphate. The salt added to the table salt to make it flow freely in rainy season. So this is about key regarding your level 1 questions. Now we are going to discuss about level 2. The electrode potential for chlorine into Cl minus is plus 1.36. For iodine, iodide is 0.53. For silver, ion in silver is 0.79. Na plus Na is 2.71, and for lithium plus lithium, ion in lithium is minus 3.04. Arrange the following species in decreasing order of their reducing strengths with respect to iodide ion, silver atom, chloride ion, lithium atom and sodium atom. In this case, you are seeing on the screen the first question is the correct option for this is the second option. See here, second option is the perfect one. Lithium, sodium, iodine, silver and chloride. Sorry. When you go for the atomic radius, lithium is smaller than sodium. Sodium is smaller than iodide. Iodide is smaller than silver. Up to here you understand. And the last one, chloride, it is a negative charge. Its value they have given in the plus form. See here, plus 1.36. Positive value is there. When you go in all the cases, the values are lesser than this chloride ion. Based upon these values, we have arranged this. So the right option is second one. Second question, which one is the highest melting halide? Which one is having highest melting point? Yes, first option. First option. Reason, lithium chloride and lithium bromide are covalent and hence their melting points are low. Amongst NaCl and NaI, the NaCl has the higher ionic character because chloride ion is smaller than iodide ion. Remember once Fazan rules in chemical bond, and hence has a higher lattice energy than sodium iodide. Therefore, sodium chloride has the highest melting point. In a mixture of lithium chloride and lithium sodium chloride, lithium chloride is separated by what method? Lithium chloride is separated by what method? Separated means extraction. To which method we can extract lithium chloride? Yes, first one only. It can extracted through extraction with pyridine. Pyridine is the organic compound. So lithium chloride is soluble in pyridine. Addition of KO2 to water makes the solution rich. When you add potassium peroxide to the water, makes the solution rich in which ions will be increases when you add potassium peroxide to the water? Yes, hydroxide ions will be increases. This is the equation. Potassium peroxide, when you replace it in water, you will get potassium hydroxide, hydrogen peroxide and water. The reactivity of alkali metal sodium with water is made use in drying of alcohols, in drying of benzene, in drying of ammonia solution as a general drying. So, absolutely the second one is the right option for this, in drying of benzene. Moisture present in benzene reacts with sodium to give NaOH and H2. Distillation of the resulting solution give dry benzene leaving with NaOH in the flask. The solubility of metal halides depends on their nature. Lattice enthalpy and hydration enthalpy of the individual ions amongst fluorides of alkali metals. The lowest solubility of lithium fluoride in water is due to. Sixth question, the right answer is second one. every time we are learning, the smaller atomic size will having higher lattice enthalpy. Seventh question. When heated in air, the excess of oxygen, the alkali metal forms various oxides. Mention the oxide formed by lithium, sodium and potassium. When heated in air, excess of oxygen in presence of, we are supplying more oxygen. The alkali metals are forming the following oxides, which is the right option. Yes, I told you, all of you, the first one forms only monoxide, that is a lithium monoxide. Second one can form peroxide and superoxide. Peroxide is there. Third one, superoxide will be formed. The right option is first one. Which is lithium fluoride almost insoluble in water, whereas lithium chloride soluble in only in water, but also in acetone. Lithium chloride soluble not only in water but also in acetone. It is soluble in both polar and non-polar. Acetone is the liquid which is a covalent compound, that is a non-polar compound. It is dissolving in both the cases because of, yes, many times repeated question, having high lattice enthalpy, high hydration enthalpy and covalent character. Which compound will show the highest lattice energy? Focus on your alkali metals which is having a smaller atomic size, which is having higher atomic size. Based on that we can decide the smaller ion in this case is sodium. So the right option is third option. Which of the following bicarbonates does not exist as a solid? Lithium bicarbonate is unstable and exists only in the solution. It is not available in the solid state. 11th question. The solubility of the following alkali metal chlorides following the order. Which is more soluble, which is less soluble? Which is more stable, which is less stable? Based on that you can decide the solubility. The stability of a compound depends upon its enthalpy of formation delta H. The more negative value of delta H shows more stability of a compound. Thus, the potassium chloride is more stable than lithium chloride because the delta H of lithium chloride is minus 408 kilojoule per mole. Delta H of KCl is minus 436 kilojoule per mole. So, the finally question number 11, the right option is the fourth one is the right option. In another way also I am explaining you. This is the experimental values, but we can't remember these experimental values. I am simply saying how to answer for this. So, potassium, cesium, sodium and lithium is there. Potassium, cesium, then after sodium and lithium. What we are observed? Lithium is the smaller. Lithium is the smaller atomic size. Definitely it is having low solubility because just you can go through the lithium. So, in all the cases cesium chloride is there, lithium chloride is there and lithium. So, this and this will get the first choice, and after that here also NaCl, here NaCl, but cesium chloride and then potassium chloride. The highest solubility is there in the potassium chloride. On heating sodium metal in a current of dry among gas, the compounds formed is. On heating sodium metal in a current of dry ammonia gas, the compound formed is. What compound will form? Sodium amide or sodamide. So, when Na is reacts with ammonia, you are getting sodamide. So, before that we will get a deep blue color, that is ammoniated electron. After that the stable compound is sodamide. Highly pure dilute solution of sodium in liquid ammonia show blue color, show conductance and reducing in nature, all of this. Yes, all of this. It show blue color when alkali metal placed into the water. It show conductance and paramagnetic nature, reducing nature, all of this. This is the equation, shows the formation of ammonium electron and ammoniated sodium. The salt on heating does not given a brown colored gases: lithium nitrate, potassium nitrate, lead nitrate and silver nitrate. Upon heating, the color will be changed. Which one is that? Yes, silver nitrate, while you heating, it will not give a brown color. Which one of the following is formed on dissolving I2 in aqueous solution of potassium iodide? Iodine is soluble in water in presence of potassium iodide, forming complex iodide. Because iodine plus potassium iodide, you are getting a Ki3. So the perfect answer is third option. Already equation I have given. When you place the iodine into potassium iodide, what product will you get it? Which of the following statement is correct for cesium bromide CbR3, which explains the correct statement? You know how to write the formula CsBr3. How will you get it? Yes, correct option. 16th question is cesium plus 1 and Br3 is minus 1. So you are getting the right option is third one. A and B are two salts, A which dilute HCl and A and B with concentrated. H2SO4 react to give a reddish brown vapor, hence A and B respectively are. What are the products will you going to get it while conducting this equation? Yes, nitrites gives nitrogen dioxide. Nitrogen dioxide is brown in color. With dilute acids, the nitrites and bromides give brown vapors of NO2 and Br2 with concentrated acid. So that the correct option is for 17th question. Fourth option is the right option. What is the product we are getting? Sodium nitrite and sodium bromide. Sodium peroxide in contact with moist air turns white dew to the formation of. Why it is turning into the white color? What is the reason? Yes, sodium peroxide, when you place it in water, you are getting sodium hydroxide plus half oxygen, half mole of oxygen. The correct option is third option, that is NaOH, forming of NaOH. On heating lithium carbonate and sodium carbonate, residue is left after heating. The weight loss is due to. Yes, formation of lithium oxide is forming. When heating upon lithium carbonate, you are getting lithium oxide and carbon dioxide. Yes, what is the right option? Third option. Third option. Evolution of carbon dioxide from lithium carbonate. From lithium carbonate, carbon dioxide is releasing. Which of the following statement is incorrect? Lithium metal is not affected by dry air. When burnt in oxygen, lithium metal forms superoxide in LiO2. Lithium combines with nitrogen directly to form Li3N. Lithium has a greatest tendency to form hydrates. Second option is incorrect option. When burnt on oxygen, lithium metal forms superoxide. No, not at all. Lithium will not form the superoxide. Anomalous properties. Lithium nitrate on heating give. When lithium nitrate, when you heat it, what product will come? Yes, same question. Nitrogen dioxide, that is brownish in color, it is coming. Third option is the correct option. The order of solubility of lithium halides in non-polar solvents follow the order. What is the correct order regarding the solubility in non-polar solvents? First one is the correct one. As the size of the anion increases from fluoride to iodide, the covalent character increases, and hence the solubility in non-polar solvents increases. The alkali metal that can react directly with carbon to form ionic carbides. Ionic carbides. So on heating, answer, lithium directly combines with the carbon. So here the right option is fourth option. Lithium only directly combine with carbon and form carbide. To form ionic carbide, this is the equation shows lithium plus 2 moles of carbon, you will get a lithium carbide. Which of the following does not illustrate the ammonia anomalous properties of lithium? Does not illustrate. Remaining 3 are anomalous properties, only one is not represent that. That is third one. Lithium much softer than the other first A group elements is wrong, is little bit hard comparing with other one. Which does not form double salt? Double salts like potassium sulfate, aluminum sulfate, 24H2O, that is called as a double salt. In this case, which will form a double salt? Yes, in alkali metals, lithium can form a double salt. Which alkali metal reacts directly towards ammonia? Lithium, sodium, potassium and cesium. Without heating, without experimental condition, which well can react directly with ammonia? Yes, which well can react? Already equation I have given. First one only, lithium. 27th question. A deliquescent white crystalline hydroxide is X reacts with a nitrate Y to form another hydroxide, which decomposes to give an insoluble brown layer of its oxide. X is a powerful catenary and breaks down the protein of skin, flesh to a pasty mass. X and Y are. So we have studied regarding NaOH. Many times we have studied this, we can see in our chemistry lab also. You can touch the NaOH, you have to feel it, whatever the question here given. So the right option is the first one. Which of the following compounds has both ionic and covalent bonds? Potassium chloride, potassium cyanide, sodium hydroxide and sodium iodide. So potassium cyanide is having both ionic and covalent bond. Very important question. Observe here. Potassium cyanide. Potassium is K plus, cyanide is minus. So both are having ionic bond is there, ionic attraction. The first case. Case number 2, C and N, in between these having a covalent bonds, a triple bond. This is covalent. Because of this reason, both are having ionic and covalent. The right option is KCN. In the synthesis of sodium carbonate, the recovery of ammonia is done by the treating ammonium chloride with calcium hydroxide. Byproduct obtained in this process is, yes, what is the byproduct will come? Yeah, first one, calcium chloride. As a byproduct means the product will be formed. Sodium nitrate decomposes above 800 degrees centigrade to give nitrogen, oxygen, nitrogen dioxide and sodium oxide. Upon heating of sodium nitrate, always you will get oxygen gas. Option 2. See, oxygen gas. Fusion of AgCl with sodium carbonate gives, in sodium fusium extract, when fusion of AgCl with sodium carbonate gas, what will you get it? Yes, you are getting the product silver carbonate and AgCl. So the first option is the correct option. When sulfur is heated with NaOH aqueous, the compounds formed are What are the products are forming? I am showing you on this screen. 4 moles of sulfur reacts with 6 NaOH. You are getting sodium thiosulfate Na2S2O3 plus sodium sulfide and water. The same way, on heating silver carbonate, we are getting silver and carbon dioxide half O2. So in this case, what is the right option for 32 question? The products we are getting is, as per the equation, we are getting this third one. Sodium carbonate solution in water is alkaline due to hydrolysis of Na plus, hydrolysis of carbonate, hydrolysis of both Na plus and CO3 minus 2 ions, and none. Which is the correct for this? Second option is the correct for this, hydrolysis of carbonate. Sodium hydride has a dash type of structure. NaH, it is ionic structure. What is the type of structure? Graphite, sodium chloride, cesium chloride, and zinc sulfide. Which one is the correct one here? The second one, it's look like a sodium chloride structure. Compounds of X and Y are obtained by the reaction of chlorine with cold and dilute sulfuric acid, dilute solution of NaOH. And compounds X and Y are formed with hot and concentrated solution of NaOH. The compounds of Y and Z respectively are chlorine reacts with NaOH, you will getting a sodium chloride plus NaClO plus H2O. When chlorine reacts with hot NaOH, you will get NaCl plus NaClO3 plus H2O. This preparation and properties of the special compounds, that is not there in your syllabus. Because of this reason, maybe you don't know the answer of these reactions. The right option for this 35 question is 2. This year in this syllabus, these are not there. When standard solution of NaOH is left in air for few hours, what the product will you get it? Yes, third option. That is, the strength of the solution will be decreases. Potassium carbonate cannot be prepared by Solvay process because, what is the reason? But sodium carbonate we are preparing by Solvay process. Why can't we prepare potassium carbonate in this Solvay process? Yes, third option is the correct one, because sodium bicarbonate is quite soluble in water. Which of the following salts would be liberate SO2 with hot and dilute H2SO4 and also decolorizes bromine water? So here one of the compound decolorize. Bromine is a orange blue color. That color will be disappear when you add the compound. Which compound will be disappear the bromine color? Option 1, option 2, option 3 and option 4. Among the 4 options, which is the right option? Absolutely the first one only, 100% right option. It decolorizes the bromine. Because of this reason, the principal products obtained on heating iodine with concentrated caustic soda solution are, see here, this equation shows the what product will be formed when iodine reacts with 6 moles of NaOH. The correct option for this is second one. So these all last 5 or 10 questions are related to important compounds. This is not there in your syllabus. Last 10 questions. If NaOH is added to an aqueous solution of zinc ions, a white precipitate appears, and on adding excess of NaOH, the precipitate dissolves. In this solution, zinc exists in the what form? Option 2 is the right option. Only 2 more questions are there. We are going to see 41. Sodium carbonate plus ferric oxide, A plus CO2. What is the A in this case? First option is the right option. Last question. Which of the following is disproportionate on heating? Disproportion, which of the following is an example for disproportion reaction? First option, this will be disproportionate. So this is about your level 1 and level 2 questions. Thank you.